Whoever invented fiber optics was truly a genius. But how did they manage to turn light into text and video? The principle behind this is incredible. We know that light travels in a straight line, but fiber optics are completely curved. How does light manage to travel inside them? Let's observe an experiment. By pointing a laser at a bottle of water, we notice that the position of the light changes. This happens due to the phenomenon of refraction. By slowly adjusting the position of the light source, we observe that the angle of the refracted beam also changes. Eventually, at a certain point, the light ends up being reflected back inside the bottle. If the angle is precise enough, the light gets trapped inside, bouncing like a ping-pong ball hitting the walls. This phenomenon is called total internal reflection. Now, by aiming the laser directly at the bottle and making a hole for the water to flow out, we see that the light follows the stream of water. Scientists use this principle to develop fiber optics, which are essentially glass wires with extremely high transparency. This glass is made of ultra-pure silicon dioxide, much purer than regular glass. When light enters the fiber at the correct angle, it undergoes repeated total internal reflections, following the curved path of the glass. This solves the problem of light traveling through winding paths. However, pure glass fibers are fragile, so they need to be surrounded by a layer of glass with a lower refractive index and then coated with a rubber layer for protection. Even so, this alone is not enough to allow transmission over thousands of miles. Light suffers attenuation along the way, so amplifiers are placed at certain points to boost the signal and ensure long-distance transmission. But how does light transform into text and images? The secret lies in the binary system. For example, when you send a message asking, "Are you there?" the cell phone signal is sent to a base station. There, it is converted into a sequence of ones and zeros. The laser emitter turns on and off rapidly, with each pulse representing a number, on for 1, off for 0. This is similar to Morse code with a flashlight. The signal travels through the fiber optic cable until it reaches the destination base station, where the light pulses are converted back into electrical signals and transmitted to an antenna. Then, the cell phone receives the signal and reverses the process, transforming it back into binary code. Finally, the words appear on the screen.